In section 1.4, numbers 25 through 40, we are using this property of combining fractions to solve. So like when I combine fractions, a over b, this one's going to be a minus, so I'll just go ahead and use, instead of using plus and minus, I'll use minus c over d. To get that common denominator, I'm going to have b times d. That means I have to multiply the a times d and b over d, which gives me the AD here, minus, and then to get that b over here, I want b over b. So I get AD minus BC. So that's where this formula comes from. It's how to combine adding and subtracting fractions. So now to apply it to this one. So in number 39, we have secant theta over sine of theta minus secant theta over secant theta. And I'll just write down the left-hand side, knowing that we want to get it to equal tan on the right-hand side. Okay, so I'm going to give a little color here to show what I did here. So the A, is the secant theta. So that's the A. So I'm going to write this is going to equal and the B, we'll do an orange, is the sine theta. And on the right hand side, B is over here and here. And we have a subtraction sign. Whoops. Actually, let's do C and D first. So C, let's do in, let's say purple. C is the cosecant theta.
I want Kayla to have a check mark.
Okay, and then the last piece is the D. And in our problem here, that's the secant. So that's here and here. And then there's a minus between AD minus BC all over B times D. So if you kind of take a moment, you can pause if you need to, and see how we're following this formula, this for to combining the fractions. So I have the first one times, well, I'll just let you look at that. Okay, so then our next step is to try to simplify that stuff. So I'm going to do an equal sign here, and then I have, let's do a highlighter. For these two pieces, that's secant squared. Okay, and then these two pieces will actually cancel each other and become one because they're multiplicative inverses. Let's see. Let's write that as, so we still have the minus there. Minus something. Oops, that's a highlighter. Minus, so sine of theta times cosecant is 1 over sine of theta. So they're inverses, so they end up canceling and just becoming 1. And all that over sine times secant. So that's sine of theta times secant of theta. Okay, going on to the next step. Just simplifying that. So secant squared theta, just want to change that to -1. And then in the denominator, I'll rewrite that secant theta as 1 over cosine theta, because I know I want to end up with something with tangent. So I know sine and cosine, sine over cosine will give me that tangent, or it's just because I want to get everything in terms of cosine and sine. Okay, now I do have a Pythagorean theorem identity that tells me that this piece is equal to, so secant squared theta -1 equals tan squared theta. So I can replace that piece with tan squared theta, and then the denominator doesn't change yet. Sine, well, actually we can just multiply those denominators together, the denominator together. So actually I'll just leave it. Do that in a different step. Okay, I just made it a little smaller so I have a little more space here. So the tan squared theta stays on top, and then I'm going to do a big fraction bar because I'm going to have this kind of fraction on the bottom where I have sine theta times 1 over cosine of theta. I can put those both as a fraction so that I can multiply them together and get sine theta over cosine theta, which is tan. So that gives me tan squared of theta over tan squared of theta. Oops, sorry, not squared in the denominator. There. And then that I can simplify. I can take a tan out of each of those. So the one tan cancels out with one of those, and I'm left with tan of theta, which was my goal. So that means my identity is proven.